Welcome to Unreal Gems. In this video, we are going to take a look at some basic PBR concepts in Unreal Engine's PBR system. I will try to make it as simple as possible so everyone can understand how it works and how to use it in Unreal Engine. Okay, so in this video series, we are going to talk about PBR or physically based rendering in Unreal Engine. For that, we first need to know what a material is, which in Unreal Engine is a combination of textures and mathematical calculations that will work together to give a certain look to a certain asset in game. So in this case, these textures are translated in game to this look of the asset. So in short, this will establish the visual style of the asset. Okay, so back in Unreal Engine, we are going to learn how to create a material for a static mesh. So if we select a static mesh, you are going to see that it has several material slots. In this case, let's create a new material for the first slot, which is quite easy. Right mouse button and choose material, or in the material section, the material option. You go ahead and click on it. I prefix it usually with an M, capital M underscore and the name. In this case, it could be PBR ball, for example. And another important thing is creating a material instance, which can be used to change parameters inside the material that we have created in an easy manner and in real time, so we can test different looks. I'm going to create one. Again, I'm going to specify the name. In this case, it's going to be MI underscore PBR ball to indicate that it is a material instance. If I wanted to use the material in the mesh, you just need to drag and drop and it will apply it. You could also drag the material to the material slot that you want, or choose the material inside the contextual menu when clicking on the material name. Okay, so now that we know what a material is and how to create it in Unreal Engine, it's time to talk about PBR, or physically based rendering, which tries to approximate the way that light behaves in the real world. This means that materials that use PBR will be usually more accurate and typically more natural looking than other materials of other shading workflows that rely on artist intuition and fiddling with parameters. So another advantage of physically based materials are that they should work equally well in all lighting environments. So for example, a material should work well at night or in daylight without having to fiddle with the parameters. Also, it's quite important to mention that this type of rendering is also applicable for stylized rendering, like for example in movies like Pixar movies or Disney movies. So one doesn't have to discount physically based rendering for this purpose, because it's going to be really important. You can see it because Pixar and Disney have been at the forefront of physically based rendering for a while, and they only pretty much do stylized 3D movies. So in this case, you can see that PBR is applicable to almost all rendering workflows. Okay, so as we have seen in the slide before, Unreal Engine has chosen PBR as its shading model. So why is this? Okay, so first of all, PBR is intuitive and consistent. So what do I mean by this? More or less, I mean that, for example, a metal object will have a parameter that will be 1 in every situation. So that means that I know that if the object is metal, it's going to have 1 in the metalness, for example, and I don't have to wonder about that. It is intuitive. I know the object is metal, so I need to have that parameter. And it is consistent, as we mentioned before. It will look good in all environments And also, for all metal objects, it will be the same. So that's why it is intuitive and consistent. Next, we have the quality it gives us, because if we are doing photorealistic rendering, it is quite good because it tries to imitate the way that light behaves in real life. So that's what we want. We are trying to imitate reality in a photorealistic render, and that's what we need for that. Next, as we mentioned before, it can also be used with stylized renderers. So it covers all of the possibilities, and in every single one of them, it has a pretty good quality. So we can get pretty good final renders. Next, and related to it being intuitive and consistent, we have the time-saving advantage. So due to it being intuitive and consistent, we have less trial and error, less fiddling with parameters without knowing what to do, just seeing the outcome. And that means that we will have a lot less time fiddling with parameters, and we will finish our work earlier. As I mentioned before, if the material is metal, it's going to have 1 in the metalness. If it's a dielectric or plastic, it's going to have 0 in the metalness. So that means that I don't need to test different values for the parameter. It's quite straightforward and quick. Next, another advantage is the compatibility advantage. What do I mean by this? Well, again, we can maintain the same look in the object in different DCC applications. So for example, if I go from Substance to Unreal, I'm going to get the same look. If I don't, it's because I do not know how to properly sample textures, or I am making a mistake in Unreal. But PBR has the potential for the object to look the same in every single DCC application. So bear that in mind. It will be quite easy to switch software or engines due to it being intuitive and consistent. So again, another advantage that being based in how light behaves in the real world provides us. And again, just for reference, you could go, instead of Substance, from Mixer to Unreal, Maya to Unreal, whatever. The material and the object should look the same. And last but not least, we need to not forget that PBR is not only about shading and materials, it is also about lighting and exposure. Okay, so now that we know that PBR is based on real-life physics, what does being a physically correct material mean? Okay, so first of all, we have a lot of equations here. Don't be afraid. I will explain everything in layman terms, so it should be quite easy to understand. And let's start first by the non-negative BRDF. So what does this mean? Okay, so a BRDF is a function that gives us the amount of light that is reflected on a surface. So in this case, light comes from the light source, it bounces on the surface, and it arrives at the camera. So the non-negative BRDF means that the amount of light reflected in the surface has to be either 0 or positive. It cannot be negative. So it cannot be a black hole, which usually is not what we want. So, okay, this is the first condition that we need to meet for a material to be physically correct. Okay, so the BRDF, so the amount of light reflected, has to be greater or equal to 0. So it has to reflect either no light or a positive amount of light. Next, we have the conservation of energy law, which means that an object will not be able to reflect more light than it receives, and that means it's quite intuitive that it cannot reflect more light than it arrived at the object. There is a small caveat in this statement, which a surface can generate light, so it can be emissive in PBR, but it's emitting light. It's not reflecting that light that it is emitting. So for light reflected, it should not be more than the surface received. Okay. Next, we have the Helmholtz reciprocity principle, which in this case means it's quite easy also that if we switch the camera with the light source, as we can see here, the measured flux in the point that we are shading, it should stay the same. Even if the camera and light switch, it should be the same. So that means that the amount of light reflected is not going to change. Be careful, this does not mean that the shadows won't change or other things. It just means that the flux stays the same in the point if you switch cameras and light sources. Okay, so next up we have the Fresnel effect, which is another physical effect that affects all materials. So the Fresnel effect means that the material will have different reflectivity depending on the angle to the camera. So head-on is going to have less reflectivity than when the camera angle it is at a grazing angle, in which we will have close to 100% reflectivity. So that's pretty much the effect. So this means that at a grazing angle we will reflect more light than if we face the surface head-on. So it is quite simple. We can see it better with this graph. You can see here a ball, and you can see that in the center the reflections are way less than in the edge, where the camera has a grazing angle, a more extreme angle, and in which we have more reflectivity. You can see it in the chart. You can see here, for example, for a chrome ball, how reflectivity evolves from the center to the edge. You can see that it starts at 75% more or less, and it will go up until the most extreme angle to camera. So the camera rays will be parallel to the surface, where it will have the most reflectivity. Same goes for the dielectrics. For example, rubber, they have a base reflectivity that is lower than metals, but they still go from, for example, in this case, 20% reflectivity to 100% at a grazing angle. So you can see the effect pretty well with these graphs. I have prepared a small shader here that makes it easier to understand how Fresnel works in PBR. So this shader is quite simple. We just have the Fresnel node, which gives us a number between 0 and 1 depending on the grazing angle of the camera. So it will be 0 in the middle, and as we get close to the edge, to the grazing angle, it will be 1. So you can see that we have a lerp which interpolates between two elements depending on the third parameter, which in this case, when it is value 0, it will choose the first color. When it is value 1, it will choose the second color. And if it's an intermediate value, for example 0.5, it will mix the colors. So for example, in this case, it would be orange mixed with green with equal parts. So you can see here clearly how Fresnel works. As we get far away from the center of the object and from we go to the grazing angle, you can see that the orange starts to show up. If we change the Fresnel exponent, you can change the way that it transitions. So for example, as you can see, you can adjust the exponent and see how it affects the Fresnel calculation, and again with the reflect fraction. Here you can see it applied to the PBR sphere, and you can see how the grazing angles change to orange in any part of the material, like for example in those edges. So as you can see, this is quite awesome to visualize how Fresnel works in our game objects. Okay, so now it's time to talk about the Unreal Engine PBR workflow. So in this case, we can have two possible workflows, the metal roughness workflow and the specular glossiness workflow. So Unreal, as I mentioned before, has chosen metal roughness, so we will look into the metal roughness maps, and we will also look at the maps common to both workflows. So in this case, we will be looking at base color, roughness, metallic, ambient occlusion, normal, and height maps. If you see some of these maps when you download PBR materials, so on and so forth, be careful because they are not compatible directly with the Unreal Engine PBR model. Especially be careful with the specular maps because in Unreal Engine materials have a specular pin, but it is not the same thing. We will explain later what the specular pin means in the Unreal Engine PBR shaders, but remember that it is not the specular maps from the specular glossiness PBR workflow. So be really careful with that. If you see diffuse, maybe glossiness maps, specular maps, you know that you need to avoid that material or convert it to a metal roughness workflow. But converting them is not straightforward. So, okay, let's look then at the first maps that we will encounter in the metal roughness workflow. Okay, so first of all, we have the base color. This map represents the color of the object, but it represents the color without specularity or shading. So that means without shadows and without specular highlights, so on and so forth. Just the pure color of the object. This means that we will have for this texture or for this parameter in a PBR shader, 3 linear RGB values between 0 and 1, being 0 black, 1 white, and for example, if we have red, pure red, it would be 1, 0, 0. So you can see that it is quite straightforward. It tries to imitate the way that light behaves in real life. You can see that if we look at a red apple, the visible color of the red apple will be the wavelength of light that is reflected from the light source to our eyes. So in this case, the skin of the apple will reflect mainly the red component of the light and will absorb the rest. That is why we only see red. So you can think that the objects emit light, but it is just that we see only the reflected light, and of course the surface of the object absorbs the rest of the light and dissipates it as heat, which is why black absorbs a lot of heat and you shouldn't wear it in sunlight because it absorbs all of the light and dissipates it as heat. Okay, so that is why the base color is what it is. Okay, so we are back in Unreal Engine and we are going to take a look at the basic PBR material that I have created so I can showcase to you all of the properties of the PBR workflow in Unreal Engine. So as you can see, the material is quite simple. It has several parameters that you create when you create a new constant. You go ahead and convert it to parameter and then you can adjust it in the material instance if you create one. And you can see that I have created a base color parameter, which is just a color, a metallic parameter, which is a constant, and a roughness parameter, which is another constant. And now we are going to be able to adjust it in the material instance. You can see right here the parameters, and let's go ahead and take a look at how the base color affects our object in the scene. Okay, so if we want to make the object red, you can go ahead and switch to red. You can go ahead and make it brighter or darker. And you can see that the color changes as I switch the base color parameter. And you can see that if we want to switch to green, we can switch to green, blue, and yellow. So this is quite straightforward. As you can see, it is a color, is no texture. As I mentioned before, there is no need for a material to have textures, although it brings a lot of detail and realism, but you can make materials without textures. So the next map that we will cover is the roughness map. This map is in charge of saying if surfaces are polished or they are a rougher surface, like a matte surface, depending on its value. So for example, here we will have a grayscale value, no 3 values, no RGB values. It could be a luminance value, so the mix of all of the 3 values, but we could use a single parameter like we saw in the shader, and it goes from 0 to 1, being 0 a mirror-like surface and 1 a matte surface. So 0 will reflect light perfectly and 1 will scatter the light reflected, so we will see a more rough surface. Unlike with metallic that we will see later, we can fine-tune the roughness value or use a texture. You can see that this will be a 0 value, so it reflects like kind of a mirror, and as we go to 1, you can see that it becomes a matte surface. This is the texture that could drive the roughness in, for example, a PBR asset. So what does this roughness parameter equal in real-life physics? So this is what happens physically when you tweak the roughness parameter. So as you go down to 0, the reflections get focused. As we see here, the rays are not scattered, but when you go to a roughness of 1, the rays of light that hit the surface are going to be scattered, and that's why you are not gonna be able to see the reflection with detail. That's why the reflections get dimmer and they get scattered and the object looks matte. So remember, focused reflection with a roughness of 0, and with a roughness of 1, scattered reflections, and you can see that the object turns rougher or matte with dimmer highlights. We can see this effect with a laser, which is a concentrated beam of light, and you can see that when it hits the surface, which in this case is a polished mirror, you can see how it bounces perfectly. But if we hit a rougher surface, when the beam of light hits the surface, it gets scattered. That's what you see with the laser, which I think explains really well visually how light behaves when it hits a surface depending on the roughness. Well, we are back in Unreal and we are going to see how the roughness parameter affects our object in our scene. So as you can see, if I start dropping the value on the parameter, the object starts getting more reflective, less matte, less rough, and we start seeing reflections until we get to 0, at which point the reflections will be focused like we saw before. As you can see, this makes it quite easy to understand how the roughness parameter affects the objects. Okay, so the last map that we are going to look at for this video is the metallic map, which says if an object is metal or not, depending on if its value is 1 or 0. We again have a grayscale value that when it is turned on, so for 1 it's going to say that a surface is metal here in the right, and if it's off or 0, it's going to be a dielectric, a plastic object, for example, which is not a metal. When it is 1, it will yield 100% specular reflection, as you can see here. So bear that in mind. We can also drive it with a texture, like here, for example, it's the texture that says where the object is metal and where it's not. You can see another example here, just so you understand properly. These are the metals and these are the dielectrics or insulators. So for example, here we have plastic, wood, things that do not conduct electricity. So that's why we say here insulators. This will be a 0 in the metalness value, and metals or conductors will be a value of 1. So it says that they are metals. There is a small caveat here, a special case in which you can have in an object places that are, for example, rusted or painted, which are not metal, and you have rusted parts which are dielectrics. So you have metal and non-metal. So that's why you need, for example, a texture that will say what parts are rusted, like the black parts. Remember, they are not metal, and non-rusted, so metal, which are 1 in the metalness value. Again, in the base color, you would have the proper colors for the different parts of the metal. So let's not get into that, but just remember that in the metalness map, you will have where there is metal and where there is not. You could also have transitional values, but the most usual thing is just having metalness of 1 or metalness of 0. Okay, so back again in Unreal, we can see that the object right now looks plasticky because it has a roughness of 0, which is polished, but it is not a metal. So it looks like a polished plastic. If we go ahead and turn up the metallic component, you can see how it behaves more like a mirror, because again, a mirror is a polished metal with 100% specular reflection. When we go up to 1, you can see that it looks a lot like a mirror. If I now switch the roughness value, you are going to see how the object is going to start resembling like a brushed metal instead of a polished mirror. So you can see how the reflection starts losing definition, as you can see. If we go up to 1, well, it will be a matte object and it will look weird because it's kind of difficult to have a metal with a roughness of 1. Can happen, maybe some paints or something like that could be like this, but you see the point. As you can see, if I turn metalness to 0, it's a matte plastic, metalness to 1 is a matte metal. Again, 0 mirror with metallic of 0 plastic, reflective plastic. Quite easy. Okay, so let's now bring these stairs from Mixer into Unreal Engine, and let's see how we can create a small basic material in PBR inside Unreal Engine with textures. Okay, so we have imported the mesh in Unreal Engine. As you can see, the default material is not the proper material, but we have here our textures. First things first, for the albedo texture or the base color texture, we need to make sure that sRGB is activated because this is a texture that has color information. That means that we need to sample the color in sRGB, which is the proper color space, so that colors appear properly, so that color information is accurate when we import the textures from Mixer to Unreal, or if we worked in Photoshop, from Photoshop to Unreal. Be careful with Adobe RGB because it is not sRGB. If we are working in Photoshop, we need to first work with sRGB so that we can properly sample the textures in Unreal Engine. Okay, so this texture is okay. Let's look at the next texture. We have the metalness. This texture has information that is not related to color. So we need to deactivate sRGB and sample this texture in linear space. Why? Because this is physical information. It's not color information. So remember to do that, or things will not look the same in Mixer and in Unreal. Last but not least, we have the roughness texture. Again, this is also physical information, so we need to deactivate sRGB again. So remember that, or it will not look the same. Once we have this, we can create our material. We go to the material. Let's use a windowed material so that we can drag and drop the 3 textures. We go ahead and drop the textures. Since we already adjusted how the texture is sampled, it will look properly here in the sampler type. Usually you will see color for colors, and for physical information you will see linear color in the sampler type. Okay, so once we have this, we can connect the textures to their proper inputs In this case, the roughness value, well, let's start with the base color first. Let's connect the RGB value to the base color. Next, we will connect the metalness to the metalness color, so the metallic pin. And last but not least, the roughness to the roughness pin. Once we have this, we can go ahead and save the material and we can take a look inside the engine. Okay, so here we have the object in the scene. Right now it looks a little dark compared to the object in Mixer because we don't have enough light, but if we change it to movable and we place it in a place with more light, like for example here, you can see that the ladder looks almost the same as in Mixer. You can see the proper metal values and all of that, but we will do another comparison so that you can see it in a similar lighting environment as in Mixer, so that you can see that it is pretty much the same. As you can see, the asset looks exactly the same as in Mixer. If we go ahead and get it bigger, you can see that the asset is virtually the same in Unreal than in Mixer. The light setup is not exactly the same, that's why there is a small difference, but you can see that they are pretty close. So to end the video, I want to leave you with some words of advice, and it is to avoid the extremes when you are creating PBR materials. So in this case, you can see here Vanta Black, which is a lab created material with carbon nanotubes. It absorbs 99.96% of light, so it is the most light absorbent material. It reflects only 0.036% light, and even this, it is not an absolute zero. So you can see that in Unreal, for example, it could be 0.0045. So it is not an absolute zero. You can tell that we need to avoid like absolute 1 or absolute 0 in our colors because they will not be present in nature. For example, coal has 0.03 in RGB, and snow, which is one of the most reflective materials in nature, is 0.9 RGB values. So as you can see, coal is quite dark and it has no 0, and snow is quite reflective and it has no 1. So you can tell that more or less we need to not have absolutes or it will look really unnatural. For an example of how unnatural can a material look, take a look at the Vanta Black in action. As soon as we apply the Vanta Black coat, you can see that we lose all detail in the surface and we can only see black or close to absolute black, and it looks really, really weird. As you can see, this is not a material created by nature, it is created by humans in a lab. Well, that has been it for this video. I hope that you have understood everything and that you have some clear concepts about the basics of the PBR system in Unreal Engine. If you want to dive deeper in the Unreal Engine PBR system, please go ahead and feel free to watch the next videos in the series. If you found the video helpful, remember to like and subscribe. We'll see each other in the next videos.